When these three columns are added, the total number of crossover events between these mutations can be calculated. And the largest number occurs between the mutations vermilion and cross-veinless. And because this column has the greatest number of flies, these two mutations thus are farthest apart from each other. So of these three genes, it is vermilion and cross-veinless which are farthest from each other. Singed is in the middle. Although it is in the middle, it is closer to cross-veinless than it is to vermilion, as can be seen by the sum totals. The smallest total is the distance between cross-veinless and singed. Thus, these two are closest to each other. One can actually use the number of recombinants to calculate the map units, which is a measurement of the distance between genes. And so, the 152 recombination events between vermilion and cross-veinless divided by the total number of flies, 962, gives us 15.8 map units which separate these two genes. Likewise, there are 14.0 map units which separate vermilion and singed when the 135 crossover events are divided by the total number of flies, and 3.2 map units which separate singed and cross-veinless when these 31 crossover events are divided by the total number of flies. A discrepancy becomes apparent because the map units between vermilion and cross-veinless, 15.8, should add up to be the sum of the map units between vermilion and singed, 14, and the map units between singed and cross-veinless, 3.2. But they do not add up. And this is because double crossovers have not been taken into account. The gene singed is in the middle. We did not know that when we began this calculation. And so therefore, the 4 flies which are singed and the 3 flies which are vermilion cross-veinless, they were not included in the number between vermilion and cross-veinless. But since now we know that singed is located in the middle, every time the gene singed moved, there were crossover events between vermilion and cross-veinless, which were not originally added to that column. In fact, it would require a double crossover. There would have to be 2 crossover events, one on either side of the singed gene, to move it with respect to the other 2 genes. And so therefore, to accommodate these double crossover events, one must take the number of singed flies, 4, and double it, because each fly represents 2 crossover events, and take the number of vermilion cross-veinless flies and double that, because each fly represents 2 crossover events, and add these numbers to the column between vermilion and cross-veinless. This then gives us 166 crossover events instead of 152, and this then gives us 17.3 map units between vermilion and cross-veinless, which is close to the sum of the 2 smaller sections. When calculating map distances, shorter distances are typically more accurate because longer distances then will incorporate more double crossovers and then even triple crossovers.